In this video, we will go through a few other concepts, related concepts surrounding, force and mass and Earth's gravity, Earth's gravity, right? And these are not fundamental concepts. The fundamental concepts are something that we have already covered, like be it force, velocity, acceleration, distance, displacement, and all. These are the fundamental aspects. The concepts, and what we're going to learn now is primarily the ones that that will help us from a practical standpoint, right? Like when we go to a shop and when we buy things, we use certain terms, right? In how we buy items of certain quantity, and when we really do some household activities or do certain engineering activities, we use certain terms, and this video is about understanding the intuition behind that. So the first thing that we will go for, the first concept that we will now explore is around mass. Okay, so I'm not going to call that concept yet, but let's build the intuition for that idea. So let's say you go to a shop and you want to buy a certain quantity of rice. Let's say you want to buy rice or sugar of quantity 4 kilograms, right? Now, when you ask the shopkeeper, what does the shopkeeper do? Typically, ideally, right? So the shopkeeper would have an apparatus, something like this, right? So he or she would have an apparatus wherein he would have two things, and in one side, he would have placed an iron. An iron object that has a mass of 4 kgs, and he or she would fill in the other side of that scale. I'm calling this apparatus is called the scale, and on the other side he or she is likely going to put that quantity of sugar, and there is going to be a needle here, right? And on the middle, right in the middle, and when the scale takes, when the scale is absolutely horizontal, it means that the needle would point straight in the center, and which means that you have actually placed an equal quantity of rice or sugar on the left hand side plate or whatever, right? So what's happening here? How was the shopkeeper actually measuring the quantity of the rice or the sugar? He or she was using gravity simply, right? He or she was making use of gravity. And what exactly was happening here was when you place that iron object of mass 4 kgs, that was under the influence of Earth's gravitational force. So which means that that mass exerted a certain force, right? And so it was trying to fall on the Earth, and that when it was exerting that certain amount of force, we call that quantity as the weight of that particular object. So the weight of an object is the force that a particular object exerts when it is under the influence of Earth's gravitational force. So in this case, we call it, okay, I've already written 4g here. So I had intended, it was supposed to be 4 kilograms all throughout. But the weight of this particular object is actually 4 times the gravitational constant g, right? So weight is the idea, which is the force exerted by the mass, right? So which means that your quantity of mass, the unit for mass is always kilograms, but the unit for weight is kilograms meter per second square, right? Because it is a force. It has a unit of force. So weight is the force exerted by an object of certain mass. So weight is force exerted by an object of mass m. So that's the usual quantity. So that's why this apparatus is called a weighing scale. Basically, we use a weighing scale to measure the mass of a particular item, which could be sugar or rice. And the idea is that we measure that mass through its weight, basically because we tend to measure the weight on both the sides. We tend to measure the force exerted on both the sides, and when the force is equal, you will have the needle to come on the right in the middle, and that's when we can infer that the quantity that you've already placed here is of mass certain kg. That equates to whatever is the quantity that you placed on the other side. So the first idea is the weight, right? So the way it differs from mass is weight. Weight has both. Weight is nothing but force, right? So the unit for weight is that of unit of force. And while the unit for mass is kilograms, right? So the second idea, as we go is let's take this example. I'm going to use a different color now. Let's say you have a wooden board and you have a needle on you want to strike that needle onto that wooden floor with a hammer. Now, how exactly would you want to would you want to strike that particular needle with that hammer? Now, if your hammer is, imagine this to be a hammer, right? You can apply the force like this, right? You can hit the nail out here, or you can hit the nail, if you place the hammer like this, sorry. May not be the best way. So if you had placed the hammer somewhat like this, right? Yeah, let's take this. Yeah, let's take this. So slightly tilted or slanted. So there are different ways you can strike that nail. What is the best way? Which way when you strike will have the best impact on that hammer? Obviously, when that if your intent is to get the nail straight into the wooden block, you will have to hit it in a way that is the hammer needs to be you have to apply it, that is hit the hammer in such a way that it is perpendicular to the surface, right? So the direction of that force, the force needs to be applied in this direction as compared to this. This is not an effective way for hitting the nail with your hammer, right? So the direction always matters, right? And if you really see here, let's take the example of you are standing on a floor, and your intent is you have a ceiling, right? You have a ceiling and you want to touch the ceiling for whatever reason. Now, how would you jump, right? You would precisely jump in the direction. You would jump in the direction perpendicular to the surface, so that you get the same amount of reaction through Newton's third law, so that you go all the way up, right? So your direction would always be, you jump in a direction that is perpendicular to the floor, right? So here again you have this idea of your direction that is perpendicular to that particular surface, which is the most effective way of applying that force. Let's take another example of you have a runner, right? This is a slightly different example, wherein you have a runner who is about to sprint, who's getting ready for a race, right? And runners will have this starter blocks, and they look something like this, right, where they'll place their legs on, and here is where that runner would this is how just think about this picture as a runner who's on his mark or his or her mark, and he's about to run, and this is the starter block of that particular runner. And if you really see here, the runner would try to maximize the force that he or she gets in the horizontal direction, right? In this direction. So that is why the runner would apply maximum force on the starter block in this direction, right? In a way, he's trying to apply the force that he's trying to apply is perpendicular to the starter block, right? And that's how he can get the maximum speed to go up front here. This is different from the how the person who is trying to hit the ceiling. The person who is trying to hit the ceiling will apply the force, will apply a vertical force that is perpendicular to the surface, so that he gets a maximum reaction force, so that will help him bounce and touch the ceiling. But in this case, he's doing the opposite. He's not pushing down, but rather he's pushing on the horizontally on the starter block, so that he can get maximum bounce in the horizontal direction. So the direction of force matters, right? For you in getting things done, in any kind of activity that you do, the direction in which you apply a force is very important, and you get the maximum effect. You get the maximum effect, or your force is really effective when it is applied in a direction that is perpendicular to the surface, right? So in this case, you have to apply that force perpendicular to the surface of the wooden block. In that case, this person has to apply the force perpendicular to the floor to get the maximum leverage. In this case, the person will have to apply a force that is perpendicular to the starter block, so that he gets the maximum leap forward, right? So force applied perpendicular to the surface is very key, and the concept and the way you define that is thrust. So the second idea that we're going to define here is is thrust, which is nothing but force, but the quantity of force that is applied perpendicular to a specific surface. Force applied perpendicular to a surface. So we have taken two concepts here, weight and thrust. So let's take the third one, the last one that we're about to cover here is so before I name that, let's take this scenario. Use a different color. Let's say you have two things. You have you have an iron box, right? We use an iron box to press our clothes, and you know how it looks. It looks something like this, and you have a handle for that iron box, and you use that to press your clothes here. Now you would apply the force on the handle, right? So that you can press, that force can be applied on the cloths that you put on the mat or on the table, and to get your clothes pressed, ironed out, right? Now let's take an example of a knife. How would you cut an apple, right? So your knife is going to be something like this. Just imagine this to be a knife, and a knife will also have a handle, right? Something like this, and think about this as the handle of your knife, and here again, and this is the sharp edge of that knife, and you have and you would apply the force here, right, to cut an apple or something. Now, in both the scenarios, you are having, you are applying a certain amount of force. You're probably applying the same amount of force here and here. But if you really notice the other side of that object, so in this case, your force is actually being, distributed on a wider area here, so that the force that you apply results in a broader area on your cloth, right? So that you are able to you can iron your clothes fairly quickly, right? And that is why this part is flat, right? It tries to maximize the area so that it is large enough so that you don't have to you don't have to keep touching every thread, iron out every thread, but rather you can you can by one single application of force you can actually press one section of your shirt or your trousers, right? So that is why it is kept to be that is why it is designed so that your force can spread for a wider area. But here the idea is that the knife is designed so that your force doesn't spread. It is always focused on a very small area, so that you can be precise in cutting the fruit. Imagine a blunt knife. A blunt knife has is fairly thicker, which means that the force is applied for in a slightly in a slightly bigger area, which means that you will not be able to cut your fruit as precisely or as easily. So it is important that and how much area that you apply a force is also very important. In some cases, you may have to apply that force on a larger area, like when you are ironing a shirt. In some cases, you may have to apply it on a very small area so that all the force goes there, so that you can be very precise in doing that task of cutting that fruit or whatsoever, right? So the aspect of force per unit area is again a very important thing that we would need to be aware of and we would use in our day-to-day life, and that is what we call as pressure. So pressure is nothing but force per unit area, and this is the third concept that we will make use of in our practical day-to-day life, which is when we say pressure is high, what we are saying here is that we are applying high force per unit area, like the case of a knife. So in this case, your knife is designed in such a way that the force that you apply here results in high pressure on the apple or the fruit, right? But here the pressure is fairly spread out, right? So this is fairly low pressure, right? So which means that the force that you apply here is distributed on a slightly bigger area here. So in both the cases, your force might be the same, but the pressure that you probably have here on an iron box is less when compared to the pressure that is that is released from a knife, right? So these are the three concepts. These are not as fundamental as what we went through earlier, like velocity, distance, displacement, or acceleration, right? Or force. But these are very useful things which we will use in our day-to-day life from a practical standpoint, which is weight, which is the force exerted by a mass of certain quantity. Thrust is again force that is applied, that is perpendicular to a particular surface, and the pressure is nothing but the force per unit area. And we know that weight unit is nothing but that of force, and thrust is also force. But what about pressure? Pressure is force times unit area, which means that the unit is the unit of force, which is kilograms. Mass times acceleration, kilograms, meters per second squared per it is per area squared, right? So you can rewrite this as kilograms, meters per second squared per meters minus squared. So this is the unit for this is the unit for pressure, and you can cancel this m. So which means that it is kilograms 1 kg per meter second squared, right? So this is the unit of pressure, and we don't normally measure pressure in this. Just the way we have the unit for force is attributed to Sir Isaac Newton. The unit for pressure is attributed to the physicist called Pascal. So we call 1 Pascal. This unit is called 1 Pascal. Okay, so I think we're good with all the aspects of force, and in the next section we will go over the influence of force as exerted by fluids. So far what we have seen is all solid objects. So in the next section we will go over the force as experienced by fluids.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.